Take my baby for a ride. Like a smooth stretching highway. Like a cool summer breeze. If my motor's running right, we might lose control tonight. Got to shake my love and squeeze. It's that bring me to my knees. So please, let's roll tonight.
Okay, hi there. Today I'm going to be covering for Pre-Calculus, Chapter 1-2 on inequalities. Here's the big thing right over here. I wrote it in red, I'm circling it in highlighter. The big thing with inequalities, anytime you multiply or divide both sides of an inequality by a negative number, you got to flip the greater than or less than sign. Okay, so keep that in mind as we're going through, because otherwise you really treat it most of the time like an equal sign. You solve it like a regular equation. So for example, if I'm over here, you treat this like an equal sign. This would be the same kind of steps you do to solve 7x equals negative 5. Now the question is, do you flip the sign or not? Well, did you multiply or divide both sides by a negative number? No, you divide it by positive 7, which means you don't flip the sign, you keep it the same, which means that's your answer. Okay. Next one. If I had this one, I'm going to divide by both sides by negative 7 here, and I get x is less than negative 35 divided by 7 is positive 5. If they asked you to graph this on a number line, you'd go over here and put a 5. This is an open dot, and oops, guess it's going the other way. Here are the numbers that are less than 5 go that way. Okay. Open dot, if it's one of these. Solid dot that has the line underneath it, greater than or less or equal to, or less than or equal to. Okay. So this one, I'm going to start by bringing, actually I'm going to get rid of these fraction. I'll multiply everything by 4, and then these are gone. And I got 3x. You have to multiply everything by 4. 4 times 6 is 24. 4x and 28. Okay. I should put that line there, but that got rid of the denominator. Okay, now this is easier to solve for those of you that don't like fractions. I mean, you certainly could have, subtracted 1x or 4 over 4x from both sides and gotten, 1/4 x or negative 1/4 x, depending on which side you brought it to. All right. But this is pretty quick and easy too. Now I'm going to bring my x's to one side. These cancel. Then I got x minus 28 is less than or equal to negative 24. Add 28. And pretty quickly I get to my answer here. X is greater than or equal to 4. Okay. And you can sometimes, if you wanted to switch them, just remember you got to flip the sign. Just read it to yourself. X is greater than or equal to 4. You can, it's the same thing, just you can go on right to left instead of left to right, okay? Either one is fine with me. I don't care if the x is on the left or the right, as long as you get it correct. All right, this is called a compound inequality because there's two of them together, which means I'm working on solving what's in the middle here, okay? So what I'm going to do is I'm going to get rid of that minus 3, but I don't just add it to 2 parts. I add it to all 3 parts, okay? So I'm trying to get the x alone, which is, usually the goal. So 12 plus 3 is 15, and 6 plus 3 is 9. Next, I can divide by 2. And then I'm left with the x in the middle. 15 over 2, 15 divided by 2 is 15 over 2. 9 divided by 2 is 9 over 2. And there it is, okay? If I was to go graphing this, make a quick number line. Here's 9 over 2. Here's 15 over 2. Let's see, they both be open dots. And this is saying, that basically the x is between those two. It's greater than 9/5 and it's less than 15/2. Sorry, 9/2 and 15/2. Okay, so that's what that looks like once you solve it down. 5, this one. All right, same idea. The only thing is it's got a fraction in the middle, which means I want to get rid of that first. So the opposite of dividing by 2 is multiplying by 2. These cancel. Then I'm left with the 2x minus 5. Negative 13 times 2 is negative 26. 13 times 2 is positive 26. And next I'm going to add 5 to all three parts. Add 5 to all three parts. And I'm left with, that's negative 21. 2x, 31. And then last but not least, I divide by 2. And running out of space. So I get x 21, negative 21 divided by 2 is negative 21 over 2. 31 over 2 is 31 over 2. Okay. And I'm just going to leave it like that. If they ask you to graph it, you go graph it. That's negative 11.5 and 15.5, whatever. This is slightly interesting. What would happen if I had one of these and I had a negative number in the middle? What happens here is you do exactly what you'd think. You'd divide everything by negative 2. And those cancel, and I'm left with the x. 6 divided by negative 2 is negative 3. 13 divided by negative 2 is negative 13/2. But remember, we divided by a negative number, which means you have to flip both of the signs, okay? So make sure you flip those, and then you'll get your answer. The x is between those two numbers, okay? And that's what would happen with that. All right, 6. So, there's two ways to do these kind of problems, and this is kind of slick, actually. If I have this number is less than 6, that absolute value, what's actually going to happen is it's going to be between 6 and negative 6, okay? And it's x minus 3. And this is a pretty easy way to solve it. I think it's kind of neat. And this works, just if it's less than. So now I can add 3 to all three parts here. And I get negative 3 is less than x, which is less than 9. And that would be your answer. Number 7 is a little different because it's a greater than. That trick really works pretty much only if it's a less than a positive number. And this is the way that we more traditionally solved it. We got case 1 and case 2. This will be the plus and this will be the minus. So either x minus 4 is greater than or equal to 7, or x minus 4, you got to flip the sign on the negative value. Remembering that anytime you got absolute value, you're going to have two cases like that. So now I can solve these two. I flip, let me write that down. Flip greater than or less than sign on negative case or value. Okay. All right. Add 4 to both sides. Those cancel. I get x is greater than or equal to 11. Add 4 to here, but it's not 11 here. It's going to be negative 3 here. So x is less than or equal to 3, or greater than or equal to 11. What does this look like? Well, let's put it on a number line here. Here's negative 3. Here's 11. Both solid dots because it's got the or equal to, which means the 11, the numbers that are greater than 11 are over here, and the numbers that are less than negative 3 are over there. So that's what your answer line, number line answers would look like. All right, how about this one? So this one's nice because it's kind of like that first one I did where it's a less than a positive one. So you can set it up like a compound if you want. You could also do case 1 and case 2. So if I go -8 and 8, then in the middle I go 2x plus 7. You could do it the other way also. Maybe I'll show you. After subtract 7, and then I got 2x -15 and 1, and then divide by 2, and I got x is between -15 halves and 1/2. Okay, and I'm missing anything? Did I drop the or equal to line under it? Okay. Suppose I'd done it the other way, where I'd gone 2x plus 7 is less than or equal to 8, or 2x minus 7 is less than or equal to -8, and I got to flip that sign, remember, when you do the negative? I mean, you'd have done the same things here. Over here, you subtract 7, you get 2x. I messed up somewhere here. What is it? They're both plus 7, so this should have been -7. Which gives you -15 and -15 halves, and over here I get the positive 1/2. And then if you put them back together, you could do this like a compound inequality because it's greater than or equal to -15 halves, or it's less than or equal to 1/2. So notice how you could put them back together and get the same thing on the left and the right. But the left way is quicker. So I'm kind of partial to that one right now. All right, this one. Here's the common mistake. Kids go, you want to make sure you get that absolute value alone before you start tackling it. Okay, so the first thing you want to do is get absolute value alone first. Okay, so once I do this, then everything's going to fall into place nicely. Is less than -2 plus 3 is 1. So now this is one of those ones where, I can go the -1 over here and the +1 over here, and then keep the 11 minus 3x in the middle, and then solve it. All right, so I'm going to subtract 11 from all three parts first, and I get -12, -3x, and -10. And then I'm going to divide by -3. And an interesting thing happens. I get 4. I got to flip the sign, flip that sign in 2 spots. I get x, and -10 divided by -3 is positive 10/3, which means x is between those two numbers. X is less than 4 and greater than 10/3. That's what it means. Usually the inequality goes the other way, but this one, it's okay. You can have the smaller one on the right. 10/3 is 3.33. So anyway, all right, that's the answer. Next, this one. This one's called a no-brainer. Tell me a number that you take the absolute value of and is greater than -8. Well, that's all of them. Okay. Or write it like that. The R with the double line is another way of saying all real numbers. So that's your solution there. Okay. There's also another no-brainer one, which is like this. Tell me which numbers you take absolute value of and have it be less than negative 11, since, those are going to be all negative numbers that are less than negative 11, which means this one's no solution. Or you can say null set, which is a 0 with a slash through it. Okay, one of those two things. They both mean the same thing. So that would be things to keep an eye out for. Next, domain interval notation. Oh, I think I've skipped one. There we go. So the domain. Domain is often restricted by two things. The first one is, what's underneath the radical. Another thing is what makes the denominator 0. So I can only take the square root of positive numbers and get real numbers, okay? So all these numbers have to be greater than or equal to 8, okay? I can't plug in 1 in there because I get negative 7 under that, and that's not a real number. So it's an imaginary number. I know we can do the eyes, but that's a special kind of thing. So we're not actually going to be doing that one. Now, if I was going to write this in interval notation, what I would do is the 8 is included, so I'm going to put a bracket there, and it goes all the way to infinity, and infinity is a kind of sidewards 8 there. Infinity is actually not included because it's infinity keeps going and going and going, so you never actually get there is the idea, so it's not included. Let me put just this right here. That one is included in solution set. And if it's that kind of bracket, it's not included. Okay, and that's called interval notation, and it's nice. It's used a lot, especially when you get to calculus, and you just write that. This is your answer right here, and then everybody reading is going to go, oh, okay, it's between 8 and infinity, and 8's included, infinity's not. So this one, what would the domain be of this? Well, it could be 5, right? Because 5 minus 5 is 0. Square root of 0 is 0. Sometimes you want to start with your number line, 5 works. Does 4 work? 5 minus 4 is 1. Square root of 1 is 1. So 4 works. Oops, wrong side. Number line should go that way. So that one did work. 4 worked. Then 3 works, right? In fact, all the negative numbers will work. I could plug in 0 and negative 1 and get, square root of 6, which means it's really, that's my solution set. But I can't have 6 because 5 minus 6 is negative 1. Okay, so it would be like this. If you wrote it as, an inequality, it'd be x is less than or equal to 5, which means if I'm going to put it into bracket notation, it goes from 5 to negative infinity. Negative infinity would be, on the left side of the number line there. And once again, infinity is not included, nor is negative infinity. 5 is included, though, because that is part of the solution, which means that is what it looks like, and that's a sloppy infinity sign, but that's infinity. The sideways 8, okay? All right, this one, 4th root. Oh, my goodness. 4th root has the same rules as second roots because it's even, all right? So you can't have a negative number under there. So it's really the same kind of thing. And if you don't know what makes the inside of the radical negative, you could always take it and set it equal to 0, which is what I'll do here. Which means you add 1, and I get 2x equals 1. Therefore, x equals 1/2 when you divide by 2. Okay, so 1/2 is good. If I plug in 1/2, I get 0. Now, what if I plug in 1? Does 1 work? Then I get 2 minus 1 is 1, so that works too. So if I'm looking at my number line here, here's 1/2, that works. We said 1 also works, which means it's this side of the number line with a solid dot. So it goes from 1/2 and goes to infinity, 1/2 is included and goes all the way to infinity. Infinity is not, so there's that solution for it. Okay. All right. Getting into the last topic here. A little while ago, we were taking this sentence and turning it into an inequality. This is the same idea, except that we're giving you the graph. But I thought I'd put it out there just like this so you could see the two, because it's really the same thing. The distance between x and -1 is at least 5 units. And you learned that this distance is absolute value. The distance between x and -1, and we put a subtraction sign in there, is at least 5 units. The 5 goes over here, which means the inequality is going to go this way because it's at least 5, so it could be 6 and it could be equal to 5. This is the inequality that I want you to come up with when I give you this graph here, okay? Which means I'm going to clean up the minus negative. And you can look at it this way too. Here's the spacing in between the numbers here. That's 5 units. It goes from -6 to 1, and it gives you goes from -1 to 4, which is both 5 units. So there's your distance. That's at least 5 units. And this is the solution set up here that they gave you with the red arrows, okay? All right, so that's the first one. This is what I'm looking for, this right here. I want you to be able to write that from the number line graph. Number 2, before I show the words, this is the problem. And they're going to say write an absolute inequality that goes with the number line. So the distance is 12. It's less than 12. It could be less than 12. It can't be more than 12, which means that, if I was using words, I would say the distance between x and 2 is no more than 12 units, okay? Which means we're going to come up with the inequality now. The distance between x and 2, so it's subtraction, and its absolute value is no more than 12 units. So here's the 12. No more is less than or equal to. Or maybe not equal to, just less than. Okay? So that's what I want you to be able to do here. I got one more here. It's a you try. Why don't you see if you can come up with it? You can keep in mind that this distance is 6 and 6. And write it down, bring it into class, and we'll pick up there tomorrow. We'll close it out with some more music. Have a great night.